Okay, so we're going to do gas stoichiometry, which is the last bit of notes before your test. I know everybody's favorite, stoichiometry, yay! So what we're going to do is we're going to combine stoichiometry and the ideal gas law. So you'll be doing a stoichiometry problem first and then using the information from that stoichiometry to answer or fill out the ideal gas law. So let's take a look at this first problem. So it says calculate the volume of carbon dioxide produced when 165 grams of butane reacts with excess oxygen gas at 35 degrees Celsius and 1.1 atm. So first thing we want to do is write out our equation. So this is going to be a combustion equation. So we have butane reacting with oxygen gas. That's going to give us carbon dioxide and water. Okay, and then we're going to balance. So we have balance, you end up with this. And our end goal is that we want our volume of carbon dioxide. Okay. We can't calculate our volume of carbon dioxide directly from the information that we have. The first thing we need to do is we need to take our amount of reactant, our 165 grams of butane, and we're going to convert that to moles of what we want, which in this case is carbon dioxide. And so for this particular problem, we're looking for CO2. We're looking for moles of CO2 because that's what we're asked. The problem's asking for volume of carbon dioxide. We need to find our moles first. So we're going to do a stoichiometry problem. So we're going to start off with 165 grams of butane. We're going to convert that into moles first, so using molar mass. Then once we're in moles of butane, then we can convert to moles of carbon dioxide using our coefficients. So moles of C4H10 will be on the bottom, and then we're going to moles of CO2, and that is a 2 to 8. Okay. All right, multiply across the top, divide by what's on the bottom. And then we're going to have 3 significant figures in our answer because that's what we started with here. And you should get 11.4 moles of CO2. All right, so now that we have moles of CO2, our second step, we can use PV nRT equals nRT, the ideal gas law, to find volume. And that's where this other information here at the end is going to come into play. So we're going to use our temperature and our pressure here that's given to us for our equation. All right, so our pressure, 1.1 atm, that's given in the problem. Volume, that's what we're looking for. N, that's our number of moles. We just calculated that in the first part, so 11.4 moles. R, that's our ideal gas law constant, is 0.0821. And then remember the units are liters times atmosphere over moles Kelvin. And then our temperature, again, is in our problem, so that's our 35 degrees Celsius. And don't forget to convert this to Kelvin. All right, we can go ahead and plug those numbers in. And then we need to solve for volume. So you're going to multiply these guys together, and then you're going to divide by that 1.1. Our answer should have 2 significant figures because of that 1.1. So when you do your 2 significant figures, you should get 290, and this is our volume, so it's going to be in liters.